Hello everyone and welcome. Have you ever wondered how we make gasoline from crude oil? Or how we create plastics from simple chemicals? A huge piece of that puzzle is a field called chemical engineering thermodynamics. It might sound complicated, but today we're going to break it down into simple ideas. At its core, thermodynamics is the science of energy. Chemical engineering thermodynamics applies these powerful rules to chemical processes and materials. It helps us understand and predict how energy, heat, and work interact with matter during chemical changes. Let's look at its key roles. First, it's all about energy balances, which is based on the first law of thermodynamics. This law simply states that energy cannot be created or destroyed. Think of it like a bank account for energy. For any process, the energy you put in must equal the energy that comes out, plus any energy that gets stored. This principle is critical for designing equipment like heaters, coolers, and reactors, ensuring they operate safely and efficiently. Next, thermodynamics tells us if a process is even possible. This is the job of the second law of thermodynamics. It deals with concepts like entropy, which is a measure of disorder. The second law says that the total disorder in the universe always increases. This fundamental rule dictates the direction of spontaneous change. It explains why heat naturally flows from a hot object to a cold one, and not the other way around. For chemical engineers, this helps predict whether a desired chemical reaction will actually happen on its own under specific conditions. Another crucial area is understanding the properties of fluids and their behavior. This is called phase equilibria. It helps us answer questions like, why does water boil at a different temperature on a mountain? Or how can we separate alcohol from water? Thermodynamics provides the tools to predict how substances behave as liquids, gases, or solids, and how mixtures will separate. This knowledge is the foundation for designing essential separation processes like distillation columns. Finally, we have chemical reaction equilibria. This tells us how far a reaction will proceed. Most reactions don't go to 100% completion. They stop at a point of balance, or equilibrium. Thermodynamics allows us to calculate exactly where that point is for a given temperature and pressure. This is incredibly important because it tells an engineer the maximum possible yield of a product, which is vital for designing an economically successful chemical plant. So, in short, chemical engineering thermodynamics is the essential science that allows engineers to design, analyze, and optimize the chemical processes that create the products we use every day. Thank you so much for watching. If you found this explanation helpful and want to see more videos breaking down complex topics, please consider liking this video and subscribing to the channel. Your support truly helps us create more content. We'll see you in the next one.